Okay, alright, so hi guys. So I'm gonna try to just finish this chapter off, like, as fast as I can, because obviously, well, the thing is that the problems that we already did, I don't want to have to do, so basically, I'm just gonna go ahead and explain the, how do I say it? What is it called? Like, the terminology of all these examples, because a lot of what we already did, or a lot of the examples when it comes to sigma notation, we already kind of did before, except we were not really given, how do I say it? Like, we were not really given the problem in sigma notation. So this video is gonna kind of be just an overview of like exactly what we've already learned about sequences and series. And this is more of a video for those of you that are looking for like an overview of everything in terms of sequences and series, because I know that I did make a few videos about it and it was a lot, and the thing is that I don't want to, like, especially for those that are just looking for an overview of everything about sequences and series, I want to also make sure that I can make a video like that. So, and I know I said that it would be kind of tiring, but at the same time, since I already kind of reviewed everything in chunks of videos, I might as well just do a quick overview of everything, right? So, like I said, an arithmetic sequence is really just this. It's arithmetic sequence is just, like I said, it is, you know, so if I write it down, arithmetic sequence is of the form a sub 1 plus, or it's a sub n equals a sub 1 plus d times n minus 1, right? Yes, and like I said, d is the common difference. Or actually, let me go to the review. Maybe that'll kind of, I'm just gonna go to the review, and I'm gonna do as many problems as I can. I'm not gonna do all of it because, again, like, I didn't go over every section in this chapter, only because once you get here, like, this is just the application part of sequences and series. So, in reality, we're just gonna do, what is it called? We're gonna do, like, the problems that are on the review, basically. So give me 1 second. Okay, so, one more thing I did want to say before we actually get started with the review, and I'm just gonna go over, like, very quickly over, I'm not gonna do the entire thing, but I'm gonna go in sections over what we already did, okay? That's only because I don't, so, in reality, I don't want to make this video extremely long. I'm probably gonna make it about an hour long, because I do, like I said, I do a lot of explanation in my videos. Anyways, we're gonna do, so part 1 is gonna be about, it's gonna be this part here. Find the first 4 terms as well as the 10th term of the sequence with the given nth term, okay? Now, we didn't go over what a factorial was, so we're not going to do this one. but I'm just gonna do one per section, okay? So let's do number 4 in this part here, okay? So number 4, and we want to find the first 4 terms as well as the 10th term, right? So we have a sub n equals n times n plus 1 over 2. And like I said, we want to find the first 4 terms as well as the 10th term. So a sub 1 is just equal to 1 times 1 plus 1 all over 2. That is equal to 1 times 2 over 2, and that is just 1. So a sub 1 equals 1. And then if we do a sub 2 is equal to 2 times 2 plus 1 over 2. So this cancels out. This is equal to 2 plus 1, which is equal to 3. So a sub 2 equals 3, right? And then a sub 3 is equal to 3 times 3 plus 1 over 2. This is equal to 3 times 4 over 2. This is equal to 3 times 2 times 2 all over 2. And this is equal to 3 times 2, which is equal to 6. So a sub 3 equals 6. And then, let me just make sure it was the first 4 terms, right? Okay, so a sub 4, this is so it's a sub 4, and then we have to find the 10th term, right? So a sub 4 is going to be 4 times 4 plus 1 over 2, which is equal to 4 times 5 over 2, which is just 20 over 2, which is 10, okay? So a sub 4 equals 10. So we know the first 4 terms. The first 4 terms are, it's going to be 1, or actually, give me a second. So a sub 1 is 1. So we have 1, 3, 6, and 10, right? So that's how you do that one. So we're going to move on to the next part. It says, a sequence is defined recursively. Find the first 7 terms of the sequence, okay? Now, we are given what... So for the first one, for example, a sub n. So here... we are given, so for example, this is number 7. Yes, number 7. So number 7 says a sub n equals a sub n minus 1. So let me plus 2n minus 1, where a sub 1 equals 1, I think. Yes. And we want to find the first 7 terms, so find the first 7 terms. So we want to know what a sub 1 is, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, and a sub 7. Okay, so we want to know what that is, right? So here, to do that, we know that a sub 1 equals 1, right? Now with that, we can say that a sub 2 is just equal to a sub 2 minus 1 plus 2 times 2 minus 1. This is equal to a sub 2. This means that a sub 2 is equal to a sub 1 plus 4 minus 1. And so we have a sub 2 equals a sub 1 plus 3. And what is a sub 1? We know that a sub 1 is 1, right? A sub 2 is equal to 1 plus 3. So a sub 2 equals 4, right? So we know, so obviously we can see a sub 1 equals 1. That's our first term, so we can kind of box that already because that's what's given to us, and it wants us to find the first 7 terms, right? So then we say a sub 3 is equal to a sub 3 minus 1 plus 2 times 3 minus 1. This is equal to a sub 3, so this means that a sub 3 is equal to a sub 2 plus, and then 2 times 3 is 6 minus 1. So then it's a sub 3 equals a sub 2 plus 5. And we know what a sub 2 is. We found it right here, right? So a sub 2 is over here. So we have a sub 3 equals 4 plus 5. So a sub 3 equals 9. Okay. And now a sub 4, so a sub 4 is equal to, it's going to be a sub, so let's see here. Give me 1 second. So it's a sub 4 minus 1 plus 2, and then it's going to be times 4 minus 1. And keep in mind the formula that we're using, right? So if you want to copy this formula down, or if you want to write it down, this is the formula, right? So we have a sub 4 equals a sub 3 plus, and then 2 times 4 is 8, and then minus 1. So we have a sub 4 equals a sub 3 plus 7. And we know that a sub 3 is 9. So you have a sub 4 equals 9 plus 7. So a sub 4 equals 16, okay? A sub 5 is going to equal to a sub 5 minus 1 plus 2 times 5 minus 1. So it's going to be a sub 5 equals a sub 4 plus 10 minus 1. So it's going to be a sub 5 equals a sub 4 plus 9. So it's going to be a sub 5 equals, and a sub 4 is 16, and then plus 9, so then a sub 5 equals 25, okay? And then finally, well, the last 2 terms that we really have to find, so a sub 6 equals a sub 6 minus 1 plus 2 times 6 minus 1. So we have a sub 6 equals a sub 5 plus 12 minus 1. We have a sub 6 equals a sub 5 plus 11. And a sub 5 is 25, so we have a sub 6 equals 25 plus 11. So then we have a sub 6 equals 36. Okay. Now a sub 7, which is finally the last term that we have to find. A sub 7 equals a sub 7 minus 1. Plus 2 times 7 minus 1. So it's going to be a sub 7 equals a sub 6 plus 14 minus 1. And it's going to be a sub 7 equals a sub 6 plus 13. A sub 7 equals 36 plus 13. So, basically, we have a sub 7 equals 49. So the first 7 terms of the sequence are as follows, and I'm going to write this down, like, just so we know exactly what we're doing, what we're looking at. We have the first 7 terms are 1, 4, 9, 16, 25, and then 36, and then 49, okay? And that is the answer to this problem. Okay? That's how you do that part. Okay? Now let's look at... So yes, these are a little bit longer depending on what term they want you to find. Or how many terms they want you to find. Okay. So this one, we're not really gonna get into this part because obviously the only reason why I say that is because this part is a little bit tricky. I mean, the first part is easy because obviously it's a sub n equals 2n plus 5. But also at the same time, you know, we have to kind of graph the terms that we found and etc. So we're just going to go ahead and skip that part. Now, let's see here. Now this part, so I'm going to do two, or actually, let's do number 15, okay? So let me do number 15. Number 15 says the following. So this is 5, 5.5, 6, 6.5, dot, 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 dot. And it wants us to know whether this is geometric or arithmetic. Or actually, hold on. If this is arithmetic or geometric. Geometric or arithmetic. Doesn't matter. But, so basically, is this geometric or arithmetic, or an arithmetic sequence? Now, remember that I said that when we have, so if you go from 5 to 5.5, how much are you adding by? That's plus 0.5. 5.5 to 6, that's plus 0.5. 6 to 6.5, that's plus 0.5, and so you keep going. Now, when there is a common difference, meaning that when you're adding or subtracting by a common term, this is arithmetic, okay? It's an arithmetic sequence. Now, let's see here. Let's look at... Let's look at number 21, okay? That one is a little bit trickier. 3/4, and then we have 1/2, 1/3, 2/9. So this, in reality, is going to be, so I believe that, so let's see here, give me 1 second, guys. This one's a little tricky. So let's just look at these two parts here, because I feel like this is the easiest part, okay? If I go from 1/3 to 2/9, and I say, okay, that is really just times 2/3, right? Well, what would happen if I did 3/4 times 2/3? That's gonna give me 6/12, which is just 1/2. So yes, every time I multiply by 2/3, that's basically the common ratio. And now I say common ratio because remember that when we keep multiplying by something, it's, you know, basically what I'm trying to say is that is the common ratio. We call that R, okay? Now we don't need to know if this series, or if this sequence converges or diverges. That is something else. And if that's something that you guys want me to go over, I will. But, you know, basically, if you need to know whether it converges or diverges, give me 1 second. Okay, so now if you want to know, like, let's say these numbers are being added, right? Let's say these numbers are being added, right? And you want to know if the series converges or diverges. So if the absolute value of R is less than 1, the series converges to a sub 1 over 1 minus R. If the absolute value of R is greater than or equal to 1, then the series diverges. Okay, that means that it doesn't really go to a specific number, if that makes sense. Now, if, let's say they give you a problem like this, where it's like, you know, they give you this sum and they want to know, determine whether the series converges or diverges. You just have to remember these two things here, okay? I didn't go over this in the previous videos, but that's only because when I was in Precalculus, we didn't really go over convergence and divergence of sequences and series, but you definitely go over this in Cal 2. This is something that you definitely go over in Cal 2, and it gets even more complicated because they start introducing other types of series, and it gets a little more hectic. So, but I'm only introducing this part. This is for geometric series, okay? This is specifically for geometric series. I'm not doing, like, alternating series or, like, all those other kinds that are, like, P-series or any other kind, because that's extremely difficult. But, yes, for geometric series, if the absolute value of R is less than 1, the series converges to S equals A sub 1 over 1 minus R. So let me just try to do an example of, like, I'm going to just try to do an example of, like, let's say we did have a problem like this, right? Yes, plus 1/3 plus 2/9 plus da 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 da. And I say find the sum of the series. Or actually, if I say determine if the series converges or diverges. And what I mean by series is I mean geometric series, right? Determine if the geometric series converges or diverges, right? Now, to know that, of course, we have to know what the common ratio is. We already know the common ratio. The common ratio is 2/3. So R equals 2/3. Now, what did we say over here? We said that if R is, if the absolute value of R, so again, let's take the absolute value of 2/3. That's just 2/3, right? And that is less than 1. So that means that the series converges to this formula here. S, so that means that the sum of this series is A sub 1 over 1 minus R. Now, in reality, it would be, so a sub 1 is 3/4 over 1 minus, and then we're going to do 2/3. So in reality, it would be 3/4 over 3/3 minus 2/3. This is equal to 3/4 over 1/3. And this is just 3/4. So 3/4 divided by 1/3. This is equal to 3/4 times 3, which is just 9/4. Okay? So that is what the series converges to. It converges to 9/4. Okay, so that is the sum. So S equals 9/4. That is what that is. And I say series because yes, a series is a sum of a sequence. That's really what all that is. It's not to be overanalyzed, okay? You're gonna do there's gonna be a lot more of these once you get to Cal 2, because they're gonna be doing telescoping series and like alternating series and P series, but you don't have to worry about that right now. But just be aware that yes, this will come back. These will come back in Cal 2. And as far as the sum notation goes, I would say that that's only done when, you know, basically summation or like sigma notation. That is done when you do, what is it called? Riemann sums, which is Cal 1. But yeah, that's not something I can do just yet. But yeah, I really want to make sure, and I want to let you guys know that yes, these do come back in Cal 2 if right now you're in Precalculus and you have to take Cal 2 in the future. So, let me go ahead and actually go back to where I was. Hold on. Okay, so let's look at this one. It says the 20th term of an arithmetic sequence is 96, and the common difference is 5. It says to find the nth term. Okay, now, we know that from our formula, we know that a sub n is equal to a sub 1 plus d times n minus 1. So, in reality, we can say that a sub 20 equals a sub 1 plus the common difference. It says the common difference is 5, right? Times, and then n equals 20. So it's going to be 20 minus 1. And we want to know what the nth term is. In other words, they want to know what the formula of this sequence is going to be, right? So in reality, you're going to do, so we know that a sub 20 is 96, so we put 96, and then it's going to be a sub 1 plus 5 times 19. So, really this is just 96 equals a sub 1 plus, and it's going to be 19 times 5, which is 9, so it's 95. So then we have minus 95 on both sides. A sub 1 equals 1, right? So in reality, it's going to be a sub n equals 1 plus the common difference, which is 5, times n minus 1. We can keep it like this, or we can simplify it even more. We can also say that this is equal to a sub n, which is equal to 1 plus 5n minus 5. We can do combining like terms, which is just a sub n equals 1 minus 5 plus 5n. And then we have a sub n equals negative 4 plus 5n, like this, or a sub n equals 5n minus 4. Okay, that's how you do this one. That is when they give you, like, if they say common difference, always think that it's going to be a, like, how do I say it, like a, kind of a linear term, okay? Okay, so this is an interesting one. This is number 25. I know I'm kind of going backwards, but I saw this one, and I feel like it's very important. It says the fourth term of an arithmetic sequence is 11, and the sixth term is 17. Find the second term, okay? Oh boy. So, we know that, let's just make a table, okay? We know that the fourth term is 11, and the sixth term is 17. And this is an arithmetic sequence, and what that means is we're going to have the following. So we're going to do a sub n equals a sub 1 plus d times n minus 1. And in reality, so if we think about it, since, so here's what, and this is where you have to listen very carefully, because I'm going to try to do something, and basically, when we have numbers, right, and like, let's say we have like 7, 9, 11, 13, 15, 11, etc., etc. And I just choose two different numbers, or two different terms. Let's say I have 2, 9, n, a sub n, and 4, 13, n, a sub n. So that means that a sub 2 is 9, a sub 4 is 13, and I want to know what is, like, I don't know, what is, let's pretend that we didn't know what this is, right? What is a sub 3, right? In reality, what you would have to do is find the slope. Just think about it that way. I know it sounds really weird, but think about it that way in this problem. Because you want to know, in reality, you want to know what the change in y is. Let's say we had this, let's say this was an x and y table. 4, 11, and 6, and 17, and you want to find, like, what is f of, hold on, what is f of 2 or whatever? I mean, obviously, yes, there's a way to do this, and that is where slope comes in. That's why I feel like this one, I don't think that this is how they would do it, but, you know, we are not sure exactly what the first term would even be. You know what I mean? It's very, how do I say it? Like, it's not that easy. Because we have to, because honestly, if you do it in the way where you say, okay, let's say you just use this formula, and you're like, okay, I know that a sub 4 is equal to 11, right? So I can say a sub 4 equals, and then, but I don't know what a sub 1 is, so I'm just going to put a sub 1, and then plus d times, and I know what n is, it's just 4 because of a sub 4, 4 minus 1. That's going to give you two unknowns in reality, because you're not going to know what a sub 1 is, and you're not going to know what d is either. So that's kind of why I'm doing it this way, because in reality, it's just going to keep going from 1 to infinity, and they're telling us that the 6th term is 17 and the 2nd term is, and they want us to find the 2nd term, basically. So let's just kind of erase this part already, since I already explained that part. So, let's see, give me 1 second. So we know that this is not geometric. We know that already. Now, if you want to find what the common difference is, in reality, the common difference, D, is equal to A sub n over n, okay? That's what that is. Now, obviously we cannot use this formula here because we don't know what A sub 1 is, but this is what it is. This is what I'm letting you guys know this is, because that is if you're ever stuck with a problem like this and you don't really know how to do it in terms of like the table. Just remember this formula here, okay? Now you can do it using the table. You can say that when n equals 4, A sub n is 11, and when n equals 6, A sub n is 17, but, and if you know how to manipulate it so that you can say, well, you know, I can say that, you know, like, for example, if you want to do it without using the formula, you can say that n and A sub n, it's just going to be 1, and then you're going to do 2, 3, and it's going to be 4, 11, 5, and then 6, 17. But what you want to know, what you want to make sure you do is that you actually do take these two that you already know and say, okay, find the slope between these two. Okay, so it's going to be 6 over 2, which is just 3, right? And let's see, hold on. Give me 1 second. So, you know that basically the common difference is 3. D equals 3. That's what it is. It's really just the slope of these two, okay? If you think about this in terms of a linear equation. Now, it's wanting us to find the fourth, or actually, the second term of this sequence, okay? Now, we know what D is already. So we can say that the common difference, because the common difference is 3, we can do plus 3 every single time we go down the grid. So, for example, since I know that this is 4, 11, that means that as I go down, I'm going to keep adding 3. Okay? So 11 plus 3, that's 14. And then 11, so as I go back up, I'm going to have to subtract 3, because that means every time I go down, I'm going to do plus 3, plus 3, plus 3, plus 3, right? So that means as I go back up, I'm going to subtract 3, okay? So it's going to be 8, so 11 minus 3 is 8, 8 minus 3 is 5, and 5 minus 3 is 2. So the answer to this one, if I want to know the second term, A sub 2 is just equal to 5. Now, let's say you don't want to do it that way. Let's say you just want to find D, and then you say, okay, well, you know, a sub n equals a sub 1 plus d times n minus 1. So you want to find the second term, right? So you're going to say a sub 2 equals a sub 1 plus 3 times 2 minus 1. But again, you don't know what the what a sub 1 is. But you can find it, right? You can find it. You can say that, for example, instead of saying a sub 2, what you're solving for, you can say, okay, well, since I don't have that, I can say that a sub 4 equals, I can say a sub 1 plus 3 times 4 minus 1. And you can solve for a sub 1 that way. So it can be, you can say, so a sub 4 equals 11 equals, and then you do a sub 1 plus 3 times 3. This is equal to 11 equals a sub 1 plus 9. If you subtract 9 on both sides, you get that 2 equals a sub 1. So that means that when n equals 1, a sub n equals 2. So then once you find that, you can go ahead and say, okay, that's when n equals 1, a sub n is 2, and the common difference is 3, so you're just going to go ahead and add 3 every single time like I did here. I'm just making sure we understand the different ways in which we can solve this problem, because this one is a little bit interesting. It's not like the ones we're always given. So, yeah. It's a very interesting problem that the book has. Okay? Now let's pretend that I have this problem, okay? Now, this is similar to the other problem that we had over here, where I said, determine if the series converges or diverges, except now, instead of given a list of numbers or an addition of numbers, we are given this in sigma notation, and I want and now I want to know the sum of this. Now I know what you're thinking, okay? You're wondering, like, how do we do this, right? Because you're thinking, like, okay, obviously if we have, let's say we have n equals 1 to 3 of k squared, or let me do n squared actually. So you would say, oh, this is just 1 squared plus 2 squared plus 3 squared. So then this would be 1 plus 4 plus 9. This is 5 plus 9. This is just 14. So you're done, right? But this, you're like, whoa, wait a minute. I wonder how to do this, because you're wondering, like, you can't, I mean, you can try. You can say 2 times 3 to the 1 minus 1 plus 2 times 3 to the 2 minus 1 plus 2 times 3 to the 3 minus 1 plus dot 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 dot. And you're wondering, like, okay, how do I get to infinity? So you're wondering, like, how do you actually find the answer to this? Because and then you start to think, well, there is no answer. Well, that's where you're wrong, because it's the exact same thing that we did over here, except like I said, it's the exact same thing we did over here, except it's just worded differently, okay? So we have to remember that this is really just, for example, it's really just saying, like, 2 times 3 to the 0 plus 2 times 3 to the first power plus 2 times 3 to the second power plus dot dot dot, and you're saying, oh, this is just 2 times, basically, yeah, this is what it's saying, and it's saying, you know, it would be plus dot dot dot, and it'd be plus 2 times 3 to the n minus 1 power. And you're, and you want to know the, how do I say it? You want to know the sum of this, right? Well, the way to do this in reality is, it's the exact same thing that we did over here. Now, remember the formula? S equals a sub 1 over 1 minus r. And, remember I said over here that if r is greater than 1, greater than or equal to 1, the series diverges. So this sum, in reality, like, we don't even have to do this, because this is only if the absolute value of r is less than 1. But here, r equals 3. So the absolute value of r is greater than 1. So therefore, this sum diverges. Okay? It's tricky because not only do you have to remember that this is not really, this is just another way of saying determine whether the sum converges or diverges. That's why it's very important to just list out the sum, and then you use this rule here. And you remember these two things, and you determine, since r is greater than 1, since the absolute value of r is greater than 1, the series diverges, okay? It's tricky. So it's very important that we know what those terms mean. Okay, so this is another one. Also, another thing they want us to know, or they want you to know in Precalculus, is how to write a sum using sigma notation. That is exactly what we were doing with this, like this, in this notation, right? So, obviously, let's just go ahead and list the numbers. 3, 7, 11, 15, 19, 22, and then dot dot dot. As we go up, we're adding by 4 every single time. So, in reality, this would just be, so the common difference, and it's very important to remember, this is like I said, any time, and I will keep saying it, any time that you add by a certain number, it is automatically an arithmetic sequence, or an arithmetic series. Okay? So the common difference here is 4. The formula for this is really a sub n equals a sub 1 plus d times n minus 1. This is the arithmetic form, like I said in the beginning of this video. So, we want to write the sum of this using sigma notation. We don't want to find the sum, but we want to write the sum, okay? At least that's what I think they're asking. I don't think they're asking us to find the specific sum if it goes to infinity. I really hope not. But even if it did go into infinity, we could still find the sum. So actually, I'll do both. Why not? So the first thing that we're going to write is we're going to do the sum, so it's going to be from n equals 1 and then it keeps going forever. It keeps going forever to infinity, right? Because it's plus a sub n. But we don't know what a sub n is. We need to know what a sub n is in order to actually finish writing the sum. A sub n is really just the first term, which is a sub 1, which is 3, plus 4 times n minus 1. So really, a sub n is equal to 3 plus 4n minus 4. So in reality, it's going to be a sub n equals 4n minus 3. I mean minus 1, excuse me. So, here we'll have, so basically we'll have the sum from n equals 1 to infinity of 4n minus 1. Now, let's go a little bit further, and let's say they also said, also find the sum of this series, okay? So not only write the sum, but find the sum of this series, right? So we have this. Right? And we want to find the sum. Now, like I said, the sum is really, okay, so here's the thing, and here's the last thing that I am probably going to go over. Now, if it is a linear term, and it wants to know, let's say, for example, let's say that we actually sketch this, okay? Let's say that this is a sub n, or this is n. This is a sub n. So we go 4 times 1 minus 1, that's 3. So it's right here. I'm going to just do a few points. 4 times 2 minus 1 is 7. So like this, right? And we know that this is a linear term. This is a linear term. So that means that if we do the sum of all the terms to infinity as basically from n equals 1 to infinity, what's going to happen? It's going to keep going on forever and ever and ever and ever and ever. So this sum diverges. Okay. Okay. And let me actually, hold on. Let me do one more. I'm going to do one more and then that'll be it for this video. So let's say we had, I don't know, hold on. So, or let's say we had, hold on, and let's say that the first term, a sub 1, is 1/5, right? And every time, and I want to find, so let's say we had let's say this said, for example, and let me actually grab this really quick and move it down a little bit. Okay, so, so let's say that this said, okay, so let's say it said find, or, write the sigma notation for the sum and find sum, and also if so basically, okay, hold on, and determine whether, actually, you know what, let me do this, hold on, I'm just gonna do, give me a second, guys. Okay, so this is a little bit of a long problem. Okay. So it says, write the sigma notation for the sum and determine whether the sum converges or diverges. If it converges, find the sum. Okay, so we obviously know that this is a, so if you look very closely and you see the pattern, it's very obvious that this is a, geometric series, okay? So we already know that this is a geometric series. Okay. Now, so what that means is basically, so we're multiplying times negative 1, 6, if you think about it. And, so that's what we're multiplying by each time. And basically, so we already know this is a geometric series. Now remember that to find the sum of a geometric series, so basically we know that the sum, or actually the formula for a geometric series, because we have to know, in order for us to write it in sigma notation, we have to know what a sub n is. We don't know that, okay? And to write what this is, we have to know what the formula for geometric series is, right? Now, a sub n, so basically we have right, so let me actually, okay, so, actually, you know what, let me do this. There we go. So, I know, like I said, this is the sum for an infinite series. And yes, it is, because, we obviously know that this is gonna go on forever. Okay? Now, I had said that if it is a linear expression, and if we have a common difference, and it's a linear expression, then it diverges. However, there's rules to this one, right? And it's, like I said, it's similar to the ones we already did in this video, but I'm just kind of putting it all together, okay? So, first, they want us to find the sigma notation, right? They want us to write the sigma notation for this. And this is really just gonna be from, because it goes on forever, it's gonna go from n equals 1 to infinity. However, we do not know what a sub n is. That's what we're gonna find. Now, we do know that, let's see here, give me 1 second. So again, I had said earlier in this video, if the absolute value of r is less than 1, the series converges to this, a sub 1, over 1 minus r. So like I said, in order to find the sigma notation, we have to know what a sub n is. Now let's go ahead and find a sub n. A sub n is going to be a sub 1, right? So a sub 1 we already know is 1/5. So a sub 1 is 1/5. And then we know the common ratio. The common ratio, in reality, the common ratio is -1, not -1/5, -1/6. Okay, so r equals -1/6. Notice that I didn't say the absolute value of r, because the absolute value of r, that's only for this part, so don't get confused. You're not going to say the absolute value of r, you're going to say r, because right here, this is just r. It's not saying 1 minus absolute value of r. If it was 1 minus absolute value of r, you would say, okay, well, yeah, you would take the absolute value. But no, and also here, it doesn't say absolute value of r, so it's wanting to know r, right? Even if it's negative, it wants to know the common ratio. The common ratio here is -1/6. So here we have 1/5, and then, so we know the common ratio is -1/6 raised to the n minus 1. So we know this is just to the 1 minus 1, right? And actually, my bad, no, this isn't, I had said a sub 1 is -1/5, my bad. I meant a sub n is going to be a sub 1, so it's -1, or it's 1/5. Not -1/5, it's 1/5 times let's see here, times r, so r is -1/6, and let me put a little bit more parentheses here, to the n minus 1. Okay, now this is going to be, so we have, if we go ahead and do this, this is 1/5 to the first power times -1/6 raised to the n minus 1 power So if we go ahead and just do laws of exponents, we're going to end up with 1/5 times -1/6 to the n minus 1 plus 1 power. This is going to be -1/30 raised to the nth power. Or you could just write it as this. But yeah, I mean, that's what it is. But to find the sum of this and to do the sigma notation, like, it would be, so let me see, hold on. It would be the sum from n equals 1 to infinity of, and you can do either one. You can say 1/5 times -1/6 to the n minus 1 power, or the sum, oh my goodness, hold on guys, the sum from n equals 1 to infinity of -1/30 raised to the n minus 1 power, or not to the n minus 1, but Or actually, hold on. It would be... Give me 1 second. Hold on, guys. Actually, guys, I am wrong. This is not... No, you don't do it this way. I do apologize. It's going to just be this, okay? It's going to just be this, and then to find the sum, now, this is the last part of this problem. To find the sum, you're just going to do the formula S equals a sub 1 over 1 minus r. Notice that this is a sub 1, this is r. So, remember that because the absolute value of r is less than 1, this would be the formula that we would use. So lastly, what you're going to do is you're going to say this is 1/5, because that's a sub 1, over 1 minus, and r is negative 1/6. So what is this going to be? This is going to be 1/5 over 1 plus 1 over 6. This is just 1/5 over 7 over 6, which is really 1/5 divided by 7 over 6. This is just 1/5 times 6 over 7, and this is 6 over 35. And yes, that's it. So therefore, the formula is the following. So it's n equals 1 to infinity of, hold on, of 1/5 times negative 1 over 6 to the n minus 1. So this is the formula, or the sigma notation. And it, this sum, or the series, converges to 6 over 35. That's the second part that we have to say, because we want to know if it converges or diverges. And then the last part is we want to find the sum. So the sum would be the following. You don't just have to include the, basically don't just include the formula of the sigma notation, but also do, let's see here, hold on. So like this. Also do the result of it, equals 6 over 35. Okay, guys, and that is it for this video. I know it was kind of crazy. In reality, I did have to reteach myself some of this stuff because it's been a while. But I really hope this video helped. And I wanted to do this because, you know, for those who are looking for more of a, like, how do I say it? For more of an overall review of sequences and series. And if there's something that I did not go over in this video, I do apologize. But yes. The main ideas are like just arithmetic sequences, arithmetic series, and geometric sequences and series, and also sigma notation. That was, and convergence and divergence of arithmetic and geometric series and sequences and series. So with that being said, guys, thank you so much for watching. If anybody has any questions, please let me know. I really wanted to make this video as fast as I could, but apparently, yes, I do want to make sure we understand everything. So, with that being said, guys, please like, comment, and or subscribe to my channel, and I will see you guys in the next video. Bye, guys.